Today we are going to find the derivative of natural log of x by using definition. So our function is natural log of x and we are using the definition of derivative to find its derivative. So the definition of derivative is dy over dx is equal to limit h approaches 0 of f of x plus h minus f of x over h. And here our function is natural log of x, so f of x plus h is simply natural log of x plus h. We simply replace x with x plus h, and minus f of x, which is simply natural log of x over h. So if you see in the numerator, we have two terms which involve natural log, and whenever that is the case, that two logs have been written and they are being subtracted, then we can use a property of logarithms which states that you can write this difference as a quotient. So we can write these two logarithms as a single logarithm and write the two terms as a quotient. So this will be natural log of x plus h over x over h. So our terms were x plus h and x, and now they will be divided. So this is our limit. We need to evaluate it to find our derivative for natural log of x. And what can we do here? We can, in the numerator, we have a logarithm, and the argument of logarithm is x plus h over x. So we can break this fraction and write it as natural log of x over x plus h over x over h. So x and x will simply be cancelled and they will give us 1. So we are left with natural log of 1 plus h over x in the numerator over h, and we are taking the limit of this expression with respect to h, and h is approaching 0. So how can we evaluate this? If we put h is basically our limit, and our limit h is approaching 0. So firstly we try putting h is equal to 0 in our fraction to see whether we can find a value or not. So if we put h is equal to 0 in the numerator, we get natural log of 1 plus 0 over x. 0 over x is 0. So the natural log of 1 plus 0, and 1 plus 0 is 1. So natural log of 1, and natural log of 1 is simply 0, because what we are asking is, because the base of the natural log is e, and natural log of 1 means that we are basically asking the question that which power should e be raised to give us 1, and that is 0. E raised to power 0 is 1. So we get 0 in the numerator, and we put h is equal to 0 in the denominator, so we get 0 by 0 form, which is a problem. And we need to get rid of this h in the denominator for us to find this limit. This is necessary because this h becomes 0 in the denominator, and that is a problem. So what can we do to cancel this h? If we look at the numerator, we can actually use power series. We have a power series for natural log of 1 plus x, and that is x minus x square over 2 plus x cube over 3 minus x4 over 4 up to so on. And we have natural log of 1 plus h over x. We don't have x here, but in place of x we have h over x, and we can use this power series by we just need to replace x with h over x in our terms. So we'll do that, and when we use power series in the numerator, we get h over x minus h over x whole squared over 2 plus h over x cube over 3 minus h over x whole power 4 over 4 up to so on. The denominator remains same, it remains h. So we need to get rid of this h, and how can we do that? If we look at our terms in the numerator, all of these terms have h over x common in them, so we can take h over x common from these terms, and when we do that, we are left with 1 minus h over x over 2 plus h over x whole squared over 3 up to so on. And this is indeed useful for us because this gives us this h over x term, and now the h in the denominator can be cancelled with this h in the numerator. So these two h get cancelled, and we are left with limit h approaches 0 of 1 over x times 1 minus h over x over 2 plus h over x whole squared over 3 minus h over x whole cubed over 4 up to so on. So we have a product and we are taking a limit of that product. So we can use a property of limits which states that you can write this product as if you have a product and you are taking its limit, you can write this as the product of two separate limits of these two expressions. So we'll apply one limit on 1 over x separately and on the second expression separately. So we are left with limit h approaches 0 of 1 over x times limit h approaches 0 of 1 minus h over x over 2 plus h over x whole squared over 3 minus h over x whole cubed over 4 up to so on. So this first limit, this is simply 1 over x because our expression doesn't have h in it and h is approaching 0, so this doesn't have any effect on this. So this is just 1 over x. The limit is 1 over x. And to evaluate this limit, we can simply put h is equal to 0 in these terms to find this limit. And when we do that, we are left with 1 over x times 1 minus 0 over 2 plus 0 over 3 minus 0 over 4 up to so on. So our derivative will be dy over dx is equal to 1 over x times 1 minus 0 over anything is 0. So all these terms become 0. So 1 minus 0 plus 0 minus 0 up to so on. And so these zeros have no meaning. So we are left with 1, and dy by dx will be 1 over x times 1, which is simply 1 over x. So this is our derivative.